Good day, everybody, and welcome to the joint TCS and Yields webinar on effective AI model risk management. Today, we're going to spend best part of an hour, both in terms of prepared presentations and discussion, but also plenty of time for Q&A on how you in your institution can take some of the theory around AI models and the implementation of AI models in institutions and implement effective model risk management tools and approaches around them. AI is growing rapidly in popularity and capability, the widespread use, and the adoption is bringing new opportunities and challenges to many institutions. This is both a time of great change, but of great uncertainty in terms of what's appropriate and what's the practical way that you can manage these kind of models. So what we wanted to do today is bring this to life in a very practical way and give you a bit of insight in terms of how to do this in practice. First of all, let's do a little bit of housekeeping. So just for those who are new to using this platform, just take a look on the right-hand side. There's most important is the Q&A button. I'd encourage, if you've got any questions at any time during our webinar today, please pop them in the chat, and should have good amount of time to cover most of them through the end of the webinar. So ask them as we go along, and we'll make sure we pick them up at the end. There's a resources hub. This has got some links to some papers and thought pieces from the speakers today. So some things you can download real time and have away with you. And then after the event, you will get a survey on how you found the webinar. We really welcome your feedback, all good and bad, things we could do better as we plan future versions of this event. So please make sure you take the benefit of using that as we go. Before we get into sort of the full discussion, let's do a quick poll. So if we can, what we thought would be useful is just to get a bit of a sense of who's logged in today. We sent the invitation out to this event to a wide variety of customers, contacts, networks across the whole of our network. So it'd be great to see what kind of people. I'm imagining we've got quite a capable audience, but everyone is welcome, even if you've never used any of the common AI or Gen AI tools. So please fill in where you think you are. And I'm sure that people are experts, so don't take the language around here being an expert as totally literal, but it does give us some idea as how many people on here are expert. And we'll look to make sure we should be able to cover all audience types. So if everybody can fill in kind of their answer on that, I think I'm going to put myself in the middle. Let's see how we're looking. Yeah, a few more people still voting. Yeah, so no one's been bold enough to put them in the expert count just yet, but a fairly good mix. Most people coming out in the moderate experience, which I think probably reflects a lot of people I talk to. They're using these tools, but both privately and in their day jobs. Depending a bit on terms of what tools their employers, the financial institution they work for, have permissioned, and maybe have a working or rough understanding of how large language models work. Obviously, there's a few people who've never used them. I'd encourage you just in your private life to get on and use ChatGPT. It's a great experience, just to give you an idea of what capabilities are there. And then we've got a sort of an equal mix between people who've not used it much, or they've used it but don't really know much about it, and those who work with it a lot. So I think that's a really nice spread of expertise, and probably reflective of kind of where the industry as a whole is. That's great. So it's good we've got a good range, and I know there's a lot of people signed up for the webinar. There's a lot of people logged in today, so that's probably a pretty fair reflection of our industry as well. So, okay, now we know who we're talking to. Let's hand you over to our first speaker. And our first speaker is going to be Mark from well, I'll let Mark introduce himself because he's a super experienced guy. But I'm looking forward to hearing Mark's perspectives on how MRM, model risk management around AI, differs from more traditional model risk management. Mark, over to you.
Thank you, Andrew, and hello, everyone. Actually, when I started doing my first validations, and that was early 2005, so 20 years ago, the term model risk was not yet existing, and there were no MRM teams actually, because they only came after 2011. So it was really a different era. So much more simple, only static models, like linear credit scorecards, capital models with fixed equations, and those frameworks we were using at the time, they served us well. But now with predictive AI and especially generative AI, we are facing really a different breed of models. They are more complex, they are less transparent, they behave in ways that's really strain the old MRM playbook. So in a nutshell, AI and Gen AI, model risk, it must contend with new risks and practices beyond traditional MRM. As one industry expert told me one time, comparing traditional model to Gen AI model is like comparing a pocket calculator to a creative intern. Okay, one gives you the same answer every time, the other one might surprise you, provide you with a sonnet, a very wild suggestion. That's really what we are facing today. So today I'd like to really explore those differences and revise the new risk created by these models, their impact on validation, testing, and how companies can adjust to these needs. So first, very, very obviously, let's start with complexity and unpredictability. Because, unlike the relatively straightforward statistical models, AI models, especially deep learning, Gen AI ones, are highly complex. Okay, they continuously learn, or at least they can, from new data, and they are very frequently retrained. It's really happening, every few weeks for the large language models, for instance. So it makes them much more powerful, but also much more unpredictable in their behavior. So these models also absorb all sorts of data, images, free text, social media feeds, while the traditional models, they only use very neat rows of columns and numeric data. So that improves insight for sure, but this introduces new risks that really were not just there before. So, for example, an ML model, it might pick up subtle patterns in calls that a linear model would never be able to consider. So that's great. But until those patterns turn out spurious and biased, then we face a problem. So these AI models, as I said, they add new risk dimensions, so bias, drift, and very specific, unique issues. Bias has always been a concern in credit or insurance model. We've seen that for a really long time, but AI really brings it front and center, because these systems, they learn from historical data, but most importantly, they can amplify unfair biases, certainly when they are being used to support decisions. So AI, model risk management, requires new techniques. So bias detection metrics, fairness constraints, but this needs to be implemented to ensure the model don't discriminate. In the past, once a model was validated and deployed, it was also stable until the next review. And as many of you might have seen, AI models are much more sensitive to data drift, and that's a theme that will keep on recurring in my talks. It's that it puts a brand new emphasis on ongoing monitoring and retraining of those models, and that's really a very significant shift for model risk functions. Model risk is no longer a periodic checkup. It's a continuous surveillance of the models and their health. And so as we also know, Gen AI brings brand new types of risk. So the hallucination being the first and foremost one. So a conventional model that might go wrong by a few percentage points, but a chatbot can completely invent a brand new piece of regulation, so brand new sections that no one heard before. So these failure modes have to be really deeply taken care of, and taking into account when deploying these models in order to catch for hallucinations and harmful content. So as I was saying, many AI models function as black boxes, and so explainability become a critical risk factor. So that led to the development of new explainable techniques, so XAI, and those need to be mastered by the model risk team. So of course, we were already using some of these techniques before. We were also using surrogate models or benchmark models. But again, all of those techniques really are even more important and needed, I would say, in a Gen AI and predictive AI context. So interpretability really becomes really one of the most important components of model risk and validation for high-stake models. And again, that means that one should not shy away from using sometimes, slightly less complex, less performant models, but certainly more transparent ones, if the context requires. So that all means that the validation function, the model risk function, needs to be recalibrated in the context of predictive and Gen AI. So in the first place, it's really not feasible to validate everything manually as we were doing still 10 years ago, and I still see some small, but still some institutions doing quite extensively. So it's really absolutely mandatory now to consider systematic automation of validation and smarter testing strategies as well. Certainly when one faces an LLM, for instance, it's absolutely impossible to test such a model in its entirety. So you can't test every prompt. So you really have, again, to think about representativeness of the testing and really consider observability metrics. So monitoring outputs for anomalies, for instance, as essential components of the validation toolkit. So it means that on top of the methodologies, really the tooling and the adopting engineering-driven processes really become an essential part of the validation activities. So that means that the profile of is also changing. It's not just a PhD statisticians, that are part of the model risk department, as they used to be some years ago when I started in this activity. But now we need to have people understanding machine learning frameworks, data engineering, and really pure programmers. That's needed for the development of these toolkits I was mentioning, but also because these models have to be considered with a very different mindset. It's really more a hacker mindset. It's about trying to break the model more than trying to understand how it works in its entirety. And this is really a very different way of proceeding. That's why we see now more and more large institutions as well, medium-sized ones, putting in place, complete model ops or model AI ops functions. Okay, really blending the development and engineering and model risk and validation activities together with a lot of automation and continuous monitoring of those models. This is really an industrialized process, okay, with automated alerts, a periodic retraining of triggers, continuous logging of model decisions, all of that really present completely as an integral part of the frameworks and the tools. I would say that if you remember, and many of you might have that as part of your model libraries, but we were talking a lot about complexity of models, as one key dimension of model risk tiering. But in all honesty, in an AI context, every model is complex. Okay, so complexity does not bring so much additional information. So possibly should one start to focus more on observability, and this is something that doesn't come from me. It comes from Agus Sargento and his many brilliant papers. But really considering observability as a key component to assess the model. So can we really try to understand, do we have metrics, do we have the right tools at our disposal to be in control of the model? Can we quickly shut it down? Can we intervene? These are really new dimensions in KPIs that should be adopted by model risk teams. And again, prioritizing monitoring and agility along the way. So in terms of governance and organization, you also have some pretty drastic changes. The MRM team, used to be part of the risk organization, but now with AI and its strategic impact it has on organization, it also means that I've seen some organizations having sometimes competing teams, those are solely dedicated to AI, so solely dedicated to the model risk related to traditional standard models. Is that why? Yeah, that's a good question. But definitely, those AI models bring a lot of attention from the leadership, and that means that should MRM really be also in part of those AI models, well, it requires really revamping the whole governance framework, the committees, and the participation and the composition of those committees. Now, also. As I was saying, and certainly when we are considering, very large language models, these models, can be used for hundreds, thousands of different applications in the business. So that means that you will not consider the model itself. You have to really concentrate all of your effort on a use case based approach to certification, to validation, okay? And that puts even more emphasis than that was already the case, but now it becomes even more crucial to really capture really well the use cases that you have in your inventories beyond the mere models, okay? Finally, as I was saying, AI models require indeed a broader set of stakeholders beyond the traditional teams. It's because you have to deal with data governance, with and the related regulations like GDPR, with cybersecurity, and also with third-party risk management has to be completely reconsidered, and the role of MRM in that. Because as you know, most of the software that your company will start using, provided from external providers, these softwares will contain AI. And so what does that mean in terms of mandate, of remit, of limitations of the MRM team? What can you do? What should you ask? How should you integrate such clause, in your contracts? I know that many banks are already integrating these elements very deeply into their contracts, but that's an extra layer of work for the MRM teams that needs to be considered, of course. And to finish a little bit, I would say that, and again, coming back to the people question and the talent question, as I said, historically, model risk management teams were essentially, composed of statisticians and people with a very good understanding of finance and the related matters. But now there's really a strong need as well to integrate into those teams pure engineering talent, because in order to build these automated platforms or to maintain them and really to have some more controls about the deployment of those models, you really need to integrate much more software engineering and data engineering expertise within the model risk management team. This is absolutely needed and will become even more so. Engineering is really the new core pillar of model risk, and it will continue to be over the years to come. So in conclusion, I would say that the journey from the historical stable assumption-driven world of model risk management to the new frontier of AI, it's not just a technical upgrade. It's really a fundamental review of how financial institutions do perceive, to measure, and to manage the risk related to algorithm. And so in this landscape, we really have some fundamental shifts. So a transition from static to dynamic models, the challenge of really moving from somehow transparent to really opaque systems, and the evolution from somehow predictable errors to really emergent risk like hallucination, where you have no clue where the things do come from, or at least you can't predict them with a lot of precision. And so the old playbooks are still good and still make sense, but really they are not sufficient. And so really we have to revisit the way we manage model risk. We have to upgrade our model risk management playbooks with the techniques that are needed to address those challenges. But I'm personally very confident, because actually we have a lot of practitioners. There is a lot of research. There are a lot of excellent tools, PyML, for instance, that are available for professionals and that can be leveraged and integrated into your frameworks. So I really look forward to the rest of the discussion, and thank you for your attention.
Thanks, Mark. Lots of great insights there. And as you said, we're in an exciting new world, some new challenges, some different kinds of challenges. So wanting to build a bit on Mark's remarks and talk about sort of a thread that we're running across almost universally across organizations as the push to roll out AI capabilities, technologies, models within the organization. Very often strong lead and push from board level, a keenness to be seen to be leading in the use of these new tools. Very often a strong lead, not surprisingly, from the technology and data science teams wanting to leverage these technologies around AI and particularly Gen AI tools. But what we're seeing is they're, in some cases, bumping into existing structures and setups, particularly around governance and control for models. So I want to just tease out a bit in terms of how you can navigate sort of how the coexistence of that control, necessary controls required for model risk management in an environment in which AI is and model type instances are proliferating in an organization. So let's sort of tease apart sort of two or three different aspects of this. I think the first part that in some ways is the least technical, but in some can often be the most challenging, and that's for organizations to have some clarity around accountabilities and responsibilities for the controls, governance, and risk management of AI models. As I said, very often the new technologies it's driven through technology areas with a big push or demand from business areas wanting to use these technologies. And it's very often or quite commonly you'll run into business areas that may not have used models much before but can see opportunities to leverage these technologies. And in some ways, they haven't got experience of dealing with the existing model risk frameworks or model risk management frameworks. They're not part of the second line, maybe. And if there isn't sort of careful consideration and discussion around how accountabilities and responsibilities work, you can end up with sort of dual processes being, an evolution of the existing model risk frameworks to take account of AI models, and then in parallel, sort of an AI governance and control framework being set up. Now, there can be good reasons and for having some distinctive parts for how the governance works. Not every aspect of AI usage is a model risk question, and clearly not every model is an AI model. But without some good clarity where all parties are clear in terms of sort of how these two processes work, you can end up with duplication and almost competition for who has control and who gets to permission or say yes to a particular model being rolled out. The people, the organizations that sort of do this most effectively are the ones who work out the smart balance of which things need to be done commonly which are common controls and processes, versus which things are distinct. And what we find is certainly sort of some of the basics around core model risk management processes of having an inventory of all of users, risk standards, tiering of instances, risk assessments. These kind of fit comfortably in the model risk management world. But some of the more business-facing or commercial considerations around model usage, don't necessarily not everything has to be made part of the model risk process. So sorting out the accountability and responsibilities is both improves effectiveness in the organisation. It'll also mean that there'll be better clarity on investment in building model risk management solutions or AI control solutions. It can also help a lot with the regulatory compliance side, where you have, for example, obviously in the US SR 11.7 and the UK SS 123, sort of one long-standing, one relatively new, but model risk management standards that people are or institutions are complying with. In contrast to the much broader, and multi-industry EU AI Act, which has some of the same kind of ideas around controls and risk assessment, but is geared towards a different set of goals. And you want to, a lot of institutions will have to comply or work to both sets of standards, and being clear about accountability and responsibilities enables you to also be clear in terms of how you meet those regulatory obligations. There's a cultural point as well, beyond the practical of how these two things coexist, which is almost like a mindset around the use of these tools. And again, I wouldn't characterize this as good or bad, it's just a different perspective. Very often we see a lot of the rollout of new AI tools. There's a strong pro-innovation, new customer service, new commercial opportunity, new cost saving. There's very much an innovation, positive looking forward agenda of why shouldn't we use this? It's going to bring benefits. A risk management process has necessarily got a risk-aware mindset. So it's sort of saying, well, we shouldn't use something until we know that it's safe and it's been checked and it does what it's supposed to do. Neither of these is good or bad, or necessarily better than the other, but certainly we see some of the tensions that institutions run into is just really to do with these two mindsets. People trying to achieve things, but with a different perspective, and some of the benefits from bringing them together and just working out kind of like how these things should coexist. What's the minimum set of controls something needs to have to use in certain cases? Certainly a common risk tiering of models or use cases of AI, Gen AI can be very helpful, because that helps bring clarity as to when sort of heavier or more intense controls are needed versus something which can be more light touch. The other aspect that's not a new topic, but has become a very much more material topic, and it happens on a couple of levels, is really then the dependency on third-party technologies. Most LLMs are, produced from large tech third-party firms, all the usual suspects, and realistically, most financial institutions are using them on the license for business purposes, but they're not looking to say, well, we'll change the way this particular model works. Now, what is happening quite commonly, these models are then being applied to individual institution data sets, and this is creating sort of safer environments or more captive environments in which these models can be used. But nevertheless, there still needs to be some appropriate due diligence in terms of understanding, well, kind of, are the constraints, are the limitations on particular LLMs from third parties that should be used in the organization. That tends to be sort of fairly straightforward, even though there's complexity. It's actually less controversial than what we find sort of a second challenge, which is not the direct use of LLMs in a financial institution, but actually working with third-party suppliers of almost any kind of service and then working out or being transparent about that as part of their service to your institution, they're using some form of AI or particularly Gen AI, LLM in the background. And we're finding it's a real challenge to get to a true sense of terms of the Gen AI dependency the organization has. So establishing effective governance control works on a couple of levels, as you said, clarity around what's important, how risk tiering, kind of making educating a much wider set of colleagues in the organization. In a traditional risk modeling world, the risk modeling teams, the business areas they work with, certain other specialist teams would be a relatively small set of employees, specialists who are aware about models and needed to care about it. In a Gen AI world, they're now becoming pervasive technologies. So the general standard and understanding of use of models needs to be increased across the much wider set of colleagues. And as I said, this can be particularly pertinent for when those colleagues are looking to use third-party tools or are already using third-party tools that may have some embedded Gen AI dependency within it. As I said, I don't view these as sort of problems. They're just a natural consequence of new technologies being rolled out and being taken up and used widely. But it does mean that the organization needs to have sort of a good quality review, discussion, and articulation, which can of how it wants to take its approach. We've seen some institutions on one end of the spectrum run into issues by permissioning, whether it's ChatGPT or some other equivalent, LLM to employees, and then without much guidance on constraints or not how much guidance control on how it's used, and that can lead to all sorts of unintended consequences. Equally so, though, we've seen organizations who are become so risk averse about sort of the unintended outcomes they might get that is almost find it impossible to move forward and permission these tools. So trying to find a happy balance, takes some effort, but is worth it just to get these tools used out in the organization. I think from a model risk management perspective, which is our focus today, I think it's a matter of how do I take this suite of Gen AI tools and instances and use cases and work with them within my model risk framework, my model risk management systems and processes. To what extent do I need to adapt them for this sort of new class of analytic types, and how do I manage the controls around them, just so that I can provide the same assurance and comfort to our stakeholders that things are as they should be. And I think that sort of takes us on to our next speaker, who can talk a bit about sort of the practical approach to how do I actually deal with this problem in practice when I've got my existing MRMs set up, but I need to adapt it for an AI and a Gen AI world. So I'll hand over to Jos, who's the fantastic industry leader with his business of Yields, to give us some of his real life experience of doing this. Jos.
Thank you, Andrew, and hi everyone. Thanks for this opportunity to talk a bit about AI model risk management and then what are important components to it. But before we do so, let's move to our second poll, which is more about trying to understand where the audience sees most value over the next 2 years. Of course, 2 years is a very long time frame for AI these days, but nevertheless, it would be really great to understand where the audience thinks they see most value. Will it be more in traditional model validation and monitoring, since Mark already hinted at the fact that you need to be able to scale out the monitoring of generative AI tools? Is it more on governance and documentation, model development support, so basically the tools used to build models faster? Or do you see maybe most value in, say, underlying optimizations related to data, but also computation infrastructure, for instance. So let's see what the audience thinks. So I'll give a few more minutes, or at least 1 more minute. However, at this moment, I cannot really see the percentages of people who have voted. So maybe, Andrew, if you can see it, you can comment on the results.
Yeah, can you hear me, Jos?
Yes, I can.
Yeah, so there's a good mix. Model validation and monitoring, maybe with a bit of a nudge from Mark, is about a third, 35%. Then there's 20-odd% for C&D, both development support and data and infrastructure. Slightly less, but I mean pretty similar for model governance. And then the always interesting other category. I'd like to know kind of the seven, won't discount that. So people who've got some other ideas. So actually, model validation ahead, Jos, but actually a fair amount of votes for all categories, which suggests to me wide application.
Yes, that's very interesting and indeed quite to be expected, given the fact that there is so much focus now on testing and monitoring of AI applications. So why not use AI to monitor itself, indeed? Okay, so let's then maybe focus a bit on, say, the topic of my talk. For today, I would really like to highlight one specific aspect, and this is that doing efficient AI risk management really is an engineering problem. So why do I say this? Well, of course, as also discussed by Andrew, when we think about adopting model risk management to also encompass managing the risks of AI, of course, there is some governance aspects, roles and responsibilities that have to be updated. So we have new stakeholders. Mark was also talking about, say, mixed teams with developers, data scientists as well. There is obviously new regulatory guidance as well. We have in Europe, for instance, the AI Act, which will soon come into play, which requires some specific attention. We have discussed about keeping an inventory of AI use cases. So these are all, say, extensions of the traditional model risk management approach. But those aspects, I would say, are fairly well understood. They evolve fairly slowly over time. And also the timescale at which you need to impact this or modify the setup is fairly long. On the other hand, keeping AI use cases reliably in production really needs to deal, if you want to do this, then you need to deal with, say, fast iterations. You can maybe sometimes even deploy AI tools that do online training, so they evolve continuously over time. You need to handle huge amounts of data. You need to be able to monitor the use cases almost in real time. So as you can see, these are all engineering tasks that really require very fast iterations, having an agile approach to managing the risks, to be able to detect them early enough so that you can do something about it. And this is really a new component that was not really present in, say, classical model risk management, since there, most of the time at least, you have fairly long amount of times to do something about an issue that is being detected. Now, in order to illustrate this a bit more concretely, and since we are a technology company, we really always like to run retrospectives, trying to learn from what went well and what went wrong over time. And if something fails completely, then we actually even run post-mortems. So I thought to run 1 or 2 post-mortems on real AI incidents. The first one I'd like to focus on is a topic related to reliability of chatbots. And as Mark also mentioned, a big issue with generative AI is hallucinations. Now, recently, I believe end of last year, there was an incident by a chatbot that was serving Air Canada passengers. So the chatbots would give information about travel policy, but actually started to invent certain aspects of that policy and gave wrong information to a certain number of travelers who then actually went to court, where it was ruled that Air Canada, of course, is responsible for the correct information of the chatbots. Something very similar happened only like 6 weeks ago, I believe, with Cursor.ai. This is a technology firm that offers an IDE. So this is a tool in which engineers write code. And this IDE is powered, like natively powered by LLMs to help with efficient coding. Now, of course, Cursor uses also a chatbot for its service desk, and that chatbot started inventing new license schemes, and actually that caused quite some damage to the company, with many users quitting the application. Now, hallucinations and related to that sycophancy, which is, say, the tendency for a chatbot to please to extreme lengths the user, is an important issue. And so how do you typically address that type of issues? Well, as a first point, like with any model, you really need to control the scope, the context of the application. Because if you have a chatbot, in theory, you could ask it any question. Therefore, it almost has an infinite amount of dimensions to be tested, which is very hard. So first topic is to really control the scope. If you build a chatbot to serve customers, for instance, then the first task that chatbot has to do is to decide whether or not a question is relevant and is actually within the context of its own knowledge base. And then secondly, once you are able to properly control the scope, then you can start measuring the accuracy and the quality of the answers. How do you do this? Well, you actually have to build question and answer pairs. This can be done in a fairly automated fashion, especially if you do have a knowledge base which contains, say, information that you as the chatbot owner consider true. And then you will start automatically feeding the chatbot with the questions and verify and permutations of the same question, for instance, adding typos or changing the name or changing the wording of the original question, and then verify that the answer remains close to the reference answer, really. So if you do this, then you can start building all kinds of metrics related to traditional performance or quality of the system, but you could also start testing for bias issues, for instance, by, say, changing a male into a female name in the prompt and see whether or not this impacts the answer. So these are the typical testing approaches that are being used for those chatbots. But as you can see, it requires quite a bit of technology. It needs ways of generating huge amounts of question-answer pairs. It needs techniques to verify whether an answer is close or far from a reference answer. And very importantly, it also requires enough time for the owner of the chatbot to actually build up a solid test base, really. So that this is very important on top of, say, my first point, which was controlling the scope. So this just to show that actually testing the quality of a chatbot is really has a very strong engineering component that is really a bit new compared to a traditional model and traditional model validation or even monitoring. In the interest of time, I'll just give a very short second example before moving on to the next topic. And the second example is actually one also from, say, from space travel, actually, not air travel, but space travel this time. But I wanted to focus on that because actually it's not a generative AI issue. It's really a more traditional machine learning issue, but you will see the same challenges coming up. So I believe slightly more than 1 year ago, the Japanese airspace company iSpace launched a lunar lander that sadly enough crashed on the moon. So what caused the crash? Well, these landers, they have quite a few different sensors on board to determine their trajectory and their position relative to the moon so that they can land safely, because the signals between Earth and the moon take too long to be able to control in real time from Earth. So what happened is that the altimeter, which basically measures the height of the lander above the surface, switched itself off because it thought it was malfunctioning, as it detected a sudden increase in the height above the surface. Why did that happen? Well, actually, the company decided very shortly before they would land that they would land in a slightly different location, which actually meant that the lander would fly over a reef that was not present before in the previous location. Because of that, there was a sudden spike in the altimeter data, and given that spike, there is always an anomaly detection algorithm running in real time on those sensors to verify that the sensor is still working correctly. That spike triggered an alert, and the system decided that the altimeter was not functioning correctly, and it switched off the sensor, causing ultimately an inaccurate positioning of the lander, and therefore it ran out of fuel and crashed on the moon. So what does that learn us? Well, as with many types of models, if you make minor changes, it's not always trivial to understand what's the impact or what's the materiality of that change, especially not if your algorithm is embedded in a very complex system, such as, for instance, a lunar lander, but also like say a market risk, a full market risk computation is also fairly complex, right? And we are not always able to identify which model modification is actually material or major versus when it is actually just a minor change. So in order to manage that type of risk, it's extremely important to have a large amount of automated testing functionality available, where you can test the algorithm in many different scenarios, but also not only in isolation, but also when the algorithm is embedded in the full system that you are using. And this type of practices are typical engineering practices. Again, in software engineering, we build 100 different types of tests, going from unit tests, integration tests, stress tests, quality tests, smoke tests, and so on. So actually, you can translate all of that onto tests that you can run on mathematical models and actually build testing infrastructure that allows you to properly trust that even if you make a modification in a very complex system, you understand what would be the consequences. Good, so these were two concrete examples where I wanted to highlight the fact that managing AI risk concretely really requires a lot of engineering practices. We have many other of those examples. So if you have questions on that, don't hesitate to ask later. But let's now maybe move to the next topic, which is to discuss a few examples from real life. And this I will do together with Andrew.
Yeah. Thanks, Jos. I mean, in some ways, I think we can also sort of start picking up some of the questions as well, because I think if a lot of the questions are geared towards that, But I think I was interested in your perspective, Jos, on where you're finding clients are, your customers are in terms of AI model risk management, whether they have a clear path on what they want to do, and it's a matter about doing it. So do you think there's now sort of a developed practice, or are we still at the working out how to do it stage?
Mm-hmm. Well, I would also be curious to hear your perspective from your customers. And Andrew, but on our side, I would say that it's a bit of a mixed state currently. So many banks, of course, have already gone through the effort of adopting their model risk management to also incorporate AI aspects. Now, when you do this, then the first item that requires quite a bit of attention is the fact that you need to manage individual AI systems or AI use cases. And typically you will have a lot more use cases than you used to have traditional models. And managing the complexity and the scale of this requires technology. So we are often brought in, of course, when technology is required. And so at this stage, I would say that many financial institutions are working on implementing technology to deal with the size, the increase and scale of the AI model risk management capabilities. In parallel, I would say that we do see quite a bit of activity in the data science team. So the first line really starting to think properly about monitoring those use cases at scale, implementing controls to verify, for instance, the scope of an application, as I just hinted at during the earlier talk.
No, and I think that's a good point, because I think it's a matter of a maturity of the organization as well. I do see, as you said, a range. Organizations that have got themselves sort of organized in a better way seem to have even though it's not so much that they've concluded and everything's done, but there's a sort of a respect for the risk process and the risk controls, but also recognition that that's not everything that's going to get done in the model risk management process. That there's a lot of what you might just normally call just good control and good governance needs to take place more broadly, and where the technology and sort of, as you said, commonly data science teams that might be pushing these technologies, that they coexist with the model risk management process in an effective way. I think, I said, we have seen competing projects at times, different parts of the same organization building inventories, building control processes, and that can go on for a while before there's a recognition that it needs to improve. I think the other thing that's I suppose that sort of we find sort of from the model risk management perspective is a lot of organizations grappling with, and not a new problem, but a sort of a very familiar choice on any sort of new initiative is sort of, do I build my own solutions? Do I buy capability in? And how much are the kind of capabilities I buy in? How much do they meet the things that I want to do, or I think I need to do? I mean, I know you'd have a sort of probably your perspective on it, Jos, but I just wonder, you're effectively obviously competing in this place, but I guess competing against in-house options in terms of thing. So what's your experience of how organizations sort of evaluate what's important to them and why they might end up sort of in a buy versus build, and what are the options in terms of obviously maybe a hybrid of the two that you find people are doing?
Yeah, that's a good question. Of course, my answer will be slightly biased on that topic, as you can imagine. I think when people consider an internal build solution, it's mostly because they feel that the organization has a lot of idiosyncrasies that are hard to manage in a vendor-based solution. And sometimes also it is related to concerns around security of the application, sensitivity of the data, and things like this. What I would say is that definitely more and more when we look at AI governance, there is a push towards more standardization by the ecosystem itself. For instance, with the AI Act, people are moving towards harmonized standards, which would ideally bring a certain amount of uniformization across the market. So this is definitely something that will help, that would help making this type of trade-offs, I would say. On top of that, a reason why customers would then more and more look for a vendor solution would be that actually also within IT teams, there is this evolution towards maybe focusing more on the aspects that really add value to the organization versus building the underlying infrastructure. So what we see is that there is a lot of focus on configurability of the application, on really making sure that the underlying infrastructure is sound, and then the business teams together with, say, the IT teams working very close to the business can make sure that, say, the vendor system is then used in exactly the right way for this specific organization. And if you are managing, if you're able to do exactly this, then actually everyone focuses on where they add most value. And this is most of the time not building underlying infrastructure, for instance, to be able to store huge amounts of AI use cases or run monitoring exercises at a very high frequency. This is not where the value comes.
Yeah. No, I'd agree with that. I think it has become specialized, and I think and I think in some ways, technology teams can have great capability, but they tend to be broader in their skill set, and they can play a better role in terms of the integration of specialist components or solutions in. I'm conscious we're running short of time, and we've sort of moved into Q&A anyway, so I want to bring Mark in to the discussion because there's a really important, good question in our Q&A list. Let's just hopefully... Mark, I wanted to pose this question to you. This way Q&A works. I ask the questions, you guys give the answers. But I thought you'd have a good perspective on this because someone's asked, Sepp has actually asked a really good question around model validation functions in the sort of this AI, Gen AI world. And, it's two parts to it, both kind of a skill set part. Is that basically requiring a broader, maybe more interdisciplinary set of skills, and then quite an interesting add-on to the question where it actually sits in the organization. Should it be part of the risk? So I know you've built a model validation business, so you're probably uniquely placed to do it. So I wonder what your thoughts is on both sort of the skill set, evolution of range of skills, but also where it sits organizationally.
Yeah, absolutely. That's a great question, and I know that Andrew, this is a question that many organizations are still facing now, because broadly, I've seen so far two different distinct approaches to really deal with where should AI risk be managed within an organization. Okay, one philosophy is to say, okay, model risk management is supposed to address all risk related to models. An AI model is a model, hence it should be addressed by model risk management. Okay, seems logical, but it's not trivial for everyone, and that's why you have and I will elaborate on that, and that's why you have a separate approach, which is okay. Model risk is built to deal with let's say regulatory models, because this is a function that was essentially created at the demand of some regulators, and so it should just concentrate on regulatory models. And so risk related to AI models, which are more business models, non-regulatory models, should be addressed elsewhere. Okay, and you really have both kind of locations, if I might say so, for AI risk management within different institutions. And sometimes you even have some that go from one to the other. Okay, because sometimes the model risk function might somehow say, okay, this should be ours, but we can't address this. We just don't have the capacity, the bandwidth in terms of resources, or the skills, or the tools to do that well as we speak. Okay, and so they put that as part of their roadmap, and they provide some guidance to other functions, the AI SAR or whatever, and the AI team, if I might say so, for should it exist, to really approach and deal with model risk in a professional manner. So that's and then progressively take over and bring back some of these models, the most critical ones, under their governance. That's what I've seen. Now, going to the question of the skills themselves, it's really a twofold question, because within MRM, as we discussed together, and yes, in particular, you really have to expand beyond your traditional statisticians and bring in the data engineers and software engineers. Okay, so that's an absolute must. But as well, in parallel to that, as part of the model risk governance, it's you have to bring in lawyers. You have to bring in other types of regulatory experts. Okay, when I was a part of a model risk committee many years ago for a systemic US bank, who was there at the table? Development, the model risk validation function, and the business. That was it. Okay. Now you really need to bring in indeed bias experts. You need to bring possibly the HR function for some models. You need to bring in, your legal guys. It's a much broader set of participants that you have at the table again, and this cross functionality is really key.
Thanks, Mark. Yeah. No, I think that's, as you said, probably the skill set's the thing to focus on, and then organizationally, that's probably less of an issue. I know we're a little bit over time, but I think there's a couple of really interesting questions we could get some quick answers to. Well, probably, I'm sure there's some good long answers, but let's try some quick answers.
Yeah.
But interested in both your perspectives. I'll chip my opinion in, but Jos, you'll probably have this, common pitfalls when integrating AI models into existing MRM frameworks. So just, what are the things for people to look out for, things to avoid?
I would say over-engineering is sometimes a bit complicated, because you have new type of models coming into an inventory that maybe already contains like lots of heavily regulated models with long, very complex processes on it. The first point is to have something simple and have a good overview of the total scope of the remit of the AI governance, really. So over-engineering, I think, would be my main pitfall.
Mark, how about yourself? What do you think things to look out for when integrating AI models into the MRM framework?
Yeah, I would say, the point I was mentioning on governance is really important. Okay, I still see many people just struggling about who's gonna be eventually accountable for the quality of these models. This is really a very, very complicated decision. And then, as Jos was saying, it's really key to keep the feet on the ground, not to lose yourself, in trying to again explore and understand these models to the full extent, because it's just impossible. Okay, it's about being pragmatic and having a reasonable level of control given the means that you have at your disposal.
Yeah, I think that's right. I think being practical. I think we've covered it today. I mean, I'll say again, it's kind of a basic point that most people have got, but that people look at use cases rather than models. And again, I think trying to build an inventory where you capture every time you use an AI and calling that a new model is the path to madness. You'll soon your inventory will be bigger than not quite the atoms in the universe, but it'll certainly be a lot bigger than you want it to be. So trying to work out the smart way to categorize the unit of thing that you're trying to control, I think, is important. I'll ask one final question, because I know we're over time, but I think it's an interesting one. And it's sort of, we've touched on regulation a bit, but I'd interested, Jos, I know you work in multiple jurisdictions as well. So there's a question really about, are the current regulatory frameworks sufficient to handle AI-driven models, or do you foresee a shift in how model risk is defined and supervised? So it's almost like, regulation defined around traditional models, does it actually work? Do you see regulators sort of evolving their perspectives to accommodate, or do you think regulation has to be revised? Jos, perhaps you go first on that.
Okay, well, of course, we have the classical model requirement frameworks, and I guess those have definitely some blind spots when it comes to AI risk management. There's, of course, plenty of guidelines nowadays on managing our AI risk management, AI governance in general, like the AI Act. There is standards as well, like the National Institute of Standards AI risk management framework. However, those are still not, it's still not clear exactly what is the status of those frameworks. To what extent is this like mandatory regulatory guidance versus some good advice, basically. And I would say that at this stage where there is so much still on the table and such a lot of, quite a bit of uncertainty, I think what we as organizations should try to do is to mitigate the risk of using AI, right? Because, for instance, the examples that I gave with the chatbots giving wrong advice, it's not really a regulatory issue, it's just a very big issue for the company itself. So you really want to protect, say, your reputation, you want to understand the risks that you are taking, and that should guide us at this stage. And of course, at some point, there will be regulation in place. But most of the times, if you already have a solid risk management practice, then becoming compliant to such a framework should not be such a big step anymore.
Yeah, and Mark, anything to add?
Yeah, very quickly, I would say that just like the model risk functions, they have to upgrade their toolkit in regards to the specificities of AI models, but so do the regulators have to as well adjust their expectations. Okay, because it's very different, and definitely you can't bring the same level of certainty to what you do given the complexity of these things, and I think that's gonna be that's gonna lead to very fruitful discussions and long discussions between institutions and regulators over the year to come.
Yeah, no, I'd agree, Mark. I think there's a ways to go yet. I'm always wary of just saying, well, new regulation will somehow solve the problem. As Jos said, perhaps we kind of know some good practice, risk management practice. AIs bring some new challenges, but it's not the first time we've had to grapple with new challenges. So, okay, I'll bring things to a close then. Mark, Jos, thanks so much for your insights. It's a great privilege to get sort of such experienced industry colleagues who are actually doing it in practice, talking about these topics. Thanks everybody for joining with us today. We had a great number of people along, some great questions, some good insights. We say if anybody's interested, if you're online or even watching this on a recording and wants to delve into some of these topics, and we could have filled a whole hour with Q&A on this. And certainly I've got enough questions to ask these guys. We could fill an hour, but if there's particular aspects that are of interest to you, something you're grappling with in your organization, it doesn't matter about whether you're looking to buy services or looking for a solution. We're always interested in having good quality conversations with industry colleagues on model risk management and AI and Gen AI model risk management. We're all traveling this journey together, and I think the more friends we have on a long, difficult journey, the better. So anyway, we really appreciate you spending time with us today. And if we don't see you online, maybe we'll see you in person at one of the many risk events. I know Jos is at a risk event at least once a week from what I see on LinkedIn. So, there's plenty of chance to interact with us. But anyway, reach out and connect with us on LinkedIn in the first instance if you want to take the conversation further or more specific into your institution. Anyway, thanks so much, and we'll see you all again soon. Thank you.
Thank you. Goodbye.
Bye-bye.